Welcome to the Keeson Landscape Smart Irrigation Trainings. I am Spencer Coffey, and today we will be discussing your introductory point of connection training. If you would like this training in writing, I have linked both an English and a Spanish version of this training in the description. Today we will be discussing what really is a point of connection. We'll define common points of connection, then run through common POC alerts, what they mean, and how to troubleshoot them. Lastly, we will go out into the field together and I will show you how I troubleshoot a faulty flow sensor. As always, you are welcome to skip ahead in this training to the sections you need, either through the timestamps provided on screen now, or through the navigational bookmarks embedded in the video. To begin our conversation about points of connection, we must define what they are and why I consider them to be indispensable parts of a complete smart irrigation setup. There's a saying in the water management industry that you can't manage what you don't measure. These points of connection are the place where you learn the ins and outs of your system, how it runs, and how you can prevent catastrophic leaks, water damage to your landscape, and being overcharged on your water bills. Now it's time to define what common POCs, or points of connection, might be in your irrigation system. First, you may see a flow sensor. A flow sensor is installed on a mainline to measure the water that moves past it. Then it will communicate those data with the controller, which uses them to ensure that your system is running smoothly. This tool also enhances your understanding of your irrigation system, because water data can now be measured in gallons instead of just minutes watered. In any case where your system may not be running smoothly, the controller uses the data from the flow sensor to communicate a couple of different tasks, which we will discuss later. For now, the POC that responds to the data given by the flow sensor is the master valve. The master valve is generally installed in conjunction with a flow sensor as your system's emergency brake. If your flow sensor detects anything out of the ordinary during your watering cycle, or even when your system isn't supposed to be watering, your master valve can close and stop all the water flowing through your system. Some other examples of POCs that you may have in your system that we will not discuss today are the backflow preventer and pump start. Alright, let's break down what's happening behind the scenes once we install a flow sensor. Different types of flow sensors measure water in different ways. Some use turbines, some use ultrasonic signals, some use magnetic fields. But the good news? Once the sensor has taken its measurement, everything from that point forward works exactly the same. The flow sensor sends out a rhythmic electrical pulse, kind of like a heartbeat, through the wire circuit. These pulses represent how much water is moving through the pipe. Then, your irrigation controller picks up that signal and decodes it. It translates those pulses into a readable number, gallons per minute. So, what you see on your controller is the actual flow rate in real time. That's what makes this technology powerful and scalable. No matter the brand or type, they all speak the same language once those data hit the wire. Alright, now that you understand the general function to the flow sensor and the master valve, we'll run through some definitions of some common alerts you may find in your WeatherTRAK system. If this isn't applicable to you, you can always skip ahead to the next chapter of the video, located at this timestamp on the screen, where we will discuss the tap test and troubleshooting problems with your flow sensor. Your WeatherTRAK controller will always send you system alerts in two categories, in either the flow or electrical category. Any flow alert indicates that there is an abnormality in how water is flowing through your system, while the electrical alerts will indicate that there is a problem in your electrical circuit. First, we will dive into the most common flow alerts, their meanings, and how to troubleshoot and solve these issues. The first flow alert we will discuss is the high flow alert, which is when the measured flow for a station is at or above a set percentage higher than the intended flow for the station. This is one of the most common alerts that you'll see in the WeatherTRAK system, and it is also one of the easiest to troubleshoot. Some common causes for this alert are a broken head, a broken lateral line, or that your station high flow threshold is set too low. To troubleshoot, simply walk out to the station that throws you the high flow alert, manually run the station from your WeatherTRAK app or from the controller, and check for breaks or leaks. If you don't find any, ensure that your high flow threshold is set to the correct value in your WeatherTRAK central programming page. If you need help with this, I have a training posted to teach you about the learn flow and programming processes linked on screen now. The next alert we will discuss is the low flow alert, which indicates that the actual flow for your station is running below your assigned percentage threshold set in WeatherTRAK Central. Again, this is a very common alert, which is also easy to troubleshoot. To troubleshoot a low flow alert, you will need to walk out into the field, manually run the station with the alert, and look for fixes as necessary. If you don't find anything, check in your WeatherTRAK programming page that your low flow threshold is properly set. Now we'll discuss no flow alerts. A no flow alert can indicate some much more serious problems with your irrigation system than the high or low flow alerts. This alert indicates that your flow sensor reads that no water is passing it when a station is supposed to be running. This could be caused by a faulty solenoid in your valve, a misfunctioning master valve, or a closed gate valve. Another common cause for this problem is a bad flow sensor. We will discuss later how to troubleshoot a bad flow sensor and wire path, but to diagnose the rest of the problems, simply do a check for these issues as you normally would. Go ensure the master valve is turned on in your controller and is set correctly. Make sure to check if there are any gate valves in the main line that are preventing your system from running. The last flow alert that we will discuss today is the Mainline Break alert. This alert occurs when the measured flow on your controller exceeds a set threshold in your WeatherTRAK programming page. These are generally the most serious flow alerts, as they can waste hundreds of gallons of water per minute and cost you even more in landscape damage. This alert can be caused by a broken mainline, fitting, or quick coupler. It can also be misfired if your mainline break threshold in WeatherTRAK Central is set too low. Ensure you make your way out to the field immediately following these alerts to fix the issues as soon as possible. Now that we've got the basics down, how the flow sensor works, and what the controller is trying to tell us, troubleshooting in the field gets a lot easier. If something's not working right in the point of connection circuit, it usually comes down to one of three places. First, check the controller interface. Is the sensor actually enabled in the controller settings? Is the flow input configured correctly? Sometimes the issue is just a simple setting that got missed. Second, take a look at the wire path. This is the physical connection from the sensor to the controller. You're looking for cuts, corrosion, loose connections, anything that could break that signal. Finally, there's the sensor itself out in the field. It might be damaged, clogged, or installed incorrectly. It happens. Once you break it down to these three zones, flow troubleshooting becomes way less intimidating. You've just got to follow the signal, step by step. Now, let's head out into the field to show you some strategies on how you can diagnose these three places. Our first step for troubleshooting our flow loop is right here at the controller interface. Let's jump right in. Now, it's important to note that even though I'm using a WeatherTRAK LC controller, this process should work not only for all WeatherTRAK controllers, but all controllers in general. The first thing that I do when I get to a controller troubleshooting flow is I open the panel and just ensure that there is both a flow and communication wire plugged into their respective ports on the controller. This tells me step one, yes, we have a flow sensor and it is plugged into our controller. Now that I've ensured our controller has wires plugged into the flow and communication, the next step I'm going to take is making sure our controller knows that it's looking for a flow sensor. To do this, I'm going to go to the flow page. Now you can see our flow sensor 1 is reading 0.0 gallons per minute. I'm going to scroll over 2 times to our points of connection page. As you can see, in this page, flow sensor 1 is registered as on. I see it all too often that I'm troubleshooting flow and I go into their controller and the flow sensor 1 is turned off. Always make sure when you're troubleshooting flow sensors are turned on in the controller. Now that we've ensured flow sensor 1 is turned on in our controller, the next thing we're going to do is called the tap test. The tap test simulates the pulses that a flow sensor might send to the controller to ensure that the controller's panel has the capability of reading that flow data. So, we're going to open our panel, examine our flow and common wires. I'm going to unplug them and plug in 2 dummy wires that I just cut myself. So, plug in one in the flow port and one in the communication port. Now, I can simulate this tapping by tapping the 2 wires together just like this. And if I do that while examining my flow panel, you can see that I have read 3.5 gallons per minute. And as I tap faster, you can see that our flow sensor registers a higher gallons per minute. This should also give you a conceptual understanding of how a flow sensor works. The faster the signal the flow sensor sends out, the more water is moving past it. Now I need to unplug these dummy wires and plug my flow and communication wires back in. Let's run through the steps that we took to check our controller's interface in the flow loop. First, we made sure that our flow sensor was plugged in. We made sure that it was turned on in our controller's programming page. And we used the tap test to make sure that our controller's panel had the ability to read the flow data that might be coming from the flow sensor. Because the controller passed all of these tests, we know that the problem in our flow loop is not with our controller. So we can head outside and test the wire path. The first step to troubleshooting your wire path in your flow loop doesn't actually start out in the field. It actually starts at the controller panel. So when we did the tap test at the controller, we could use the flow menu to observe how many gallons per minute our controller was reading. When we're out in the field, however, this is not going to be possible. So let me show you a workaround. The first thing we're going to do is we're going to go to Reports. We're going to scroll to the Flow report type using the plus and minus arrows. We're going to select the flow sensor that we want to run the report on. And we can see that today we've used 672 gallons of water. Now we're going to go out into the field, tap test our flow loop, and if our flow loop and wire loop is good, then this number should increase because we're simulating flow from the field. If this number does not increase, then we know that the problem in our flow loop is the wire path. Now that we've checked our flow data for today from the controller panel, we're ready to come outside and try our tap test from the field. Now, the tap test from the controller was testing if our controller had the ability to locally read flow data. Now that we've ensured that it does have that ability, we can come out to the field and test that our wire loop has the ability to carry that flow data to and from the controller. If our wire loop does have this ability, then we can conclude that the problem in our flow loop is with our flow sensor. If our wire doesn't carry that flow data, we can conclude that we have a bad wire loop and there might be a cut or damaged wire somewhere between this flow sensor and our controller. So, the first thing we're going to do is we're going to take out our wires from our flow sensor. We're going to cut off each DBRY. Now that our flow sensor wires are separated from the wires that run to our controller, we can simply trim the wires that run to our controller and tap them together. Now, one thing that I check for every time that I'm diagnosing a flow loop is looking at the color of these wires. If these wires are copper colored, that's a wonderful sign. But if they've been corroded, they have a harder time carrying signal. So ensure that your wires are copper colored as you're tapping them together. Now that we've concluded our tapping, let's head inside and make sure that our controllers read those pulses that's coming through the flow loop. Taking a quick stop back at our panel after doing the tap test, you can see that our daily usage has increased from 672 gallons to 675 gallons. This tells me that our wire path is good and it can carry the flow signal. So let's head back outside and close everything back up. Now that we've ensured our controller can read the pulses coming through the flow loop, we can conclude that there is no problem with the wire path in our flow loop. Now, the only thing that leaves is our flow sensor. And what I normally do when I conclude that the problem is the flow sensor is I check the wires on the flow sensor to make sure there are no nicks, and then I'll go replace the body of the flow sensor to see if I can get another flow sensor to read the flow data coming through this pipe. Now that we've broken down all 3 places where there could be a problem in your flow loop, troubleshooting your flow loop should be super easy. Now, all we have to do to finish this project up is strip the wires coming from our flow sensor and put wire nuts back on everything that we took wire nuts off of. Today, we covered the basics of POC control and troubleshooting, as well as how to troubleshoot a flow loop from the field. Thank you so much for sticking around to the end of the video. If you have any questions, comments, or concerns, you can reach out to me or the great folks behind the Keeson information email provided on the screen. If you need more videos like this one, make sure to check out my YouTube channel or the Heartland University of Excellence for more uploads. As always, happy watering.